Yes.
Okay, that's okay. Thank you.
Thank you. Okay, I hope the videos that I have in the presentation will work properly over Zoom. But thank you very much for having me. It's a pleasure and an honor to be in this company today to share the work that we have been doing at the Animal-Computer Interaction Laboratory at the Open University. My apology, I used to speak and write decent French, but my French is very rusty, so I have to present in English. So I wanted to tell you a bit today about what animal-computer interaction is, what it's involved in doing animal-computer interaction research, and why it matters. So animals has been exposed to technology for many decades. Technology has been happening to animals for a very long time. However, how does technology impact on animals' well-being? How does technology influence their social lives? How easy is the technology that we design for them to use? And how do animals experience technology? And how does technology affect animals' security and even privacy? And do these questions, does this matter? And how does technology that we ask animals to use, how does it support them in the tasks that we ask them to do for us? So this is the kind of questions that the emerging field of animal-computer interaction is grappling with, is trying to address. So animal-computer interaction takes input from a number of disciplines, from biology, technology, and culture, such as ergonomics, cognition, behavior, welfare, or engineering, computing, informatics, design, as well as geography, anthrozoology, ethnography. So all these different fields have an input in helping animal-computer interaction address the questions that it does aim to address. So in 2011, we started at the Open University the Animal-Computer Interaction Laboratory on a mission to advance the art and science of designing animal-centered interactive systems for a participatory multi-species society. We have three fundamental aims. One is to investigate the interaction between animals and technology within their habitual contexts, whether these interactions are direct or indirect, dyadic or distributed, active or passive, intentional or unintentional, cognitive or physical, whatever kind of interaction. The other aim is to design computing technology that can improve animals' welfare, that can support animals in their activity, and that can foster intra and interspecies relationships with an emphasis of human-animal relations. And thirdly, a very important aim that we have is to inform animal-centered approaches to developing technology, not only for animals, but with animals as legitimate stakeholders and design contributors. So we have, over the years, it sort of worked on a wide range of projects and a wide range of research questions. I do not have time today to explore all of them. So I have picked a few examples to illustrate the kind of challenges and questions we address, the way we address them, and also why it matters that we address those issues. So firstly, I like to start with this project. This was the doctoral work of Patrizia Paci, co-supervised with me by Professor Blaine Price. And the project focused on improving the wearability of animal biotelemetry. So it's that technology that we put on animals to record their activities, perhaps their biological and physiological signs, etc. So biotelemetry is increasingly used to monitor animals for conservation purposes, research purposes, or even husbandry purposes, where we put it on pets, laboratory animals, or we put it on wild animals, sometimes with the best intentions. However, the problem is that animal wearers, who are the primary stakeholders, have no control over the use of the technology. We just stick it on them and that's it. So these devices can interfere with the animal's body and activities, sometimes causing injuries, or maybe they may get them stuck in vegetation. They may slow them down as they hunt or as they run away from predators. They may mess up their camouflage, and all of these things reduce the welfare of the animals, and also consequently the quality of the data that is recorded through these devices, which defeats the purpose of using the devices in the first place. So the existing design guidelines are still quite coarse and ad hoc. So, for example, there is a rule that says that the weight, the mass of a biotelemetry wearable must not be more than 3 to 5% the body mass of the animal. But if you think about it, if you weigh 50 kilos, with such a percentage means going around with a 2.5 kilo object weighing on your neck, which is not very comfortable at all. What we wanted to do was to also see whether the commercial devices that are sold on the market for pets, which are marketed as pet friendly, whether they were really as friendly as the advertising says. So Patrizia conducted an ethological observation of 2 different tracking devices, Potrax and Tractive, to see how the cats, for which they were intended, how they responded. She recorded over a period of time using a specially designed protocol, particular behavioral signals of discomfort. These are general signals of discomfort that cats exhibit when they are not too happy, like grooming, shaking, or scratching. But she also recorded behavioral signs of discomfort that were directed at the devices themselves, like licking, cuffing, biting the device. And of course, it turned out that the cats were not really that happy. So the devices were not really that cat friendly. So Patrizia developed a framework, a design framework, an animal-centered design framework to improve the wearability of biotelemetry intended for animals. So the framework included some values, critical values, and some design principles. For example, the device should be imperceptible to the animal. Sensory capacities should be physically unobtrusive and should be cognitively acceptable. The animal should accept the presence of the device. So these principles do not just apply to the animal wearer, but also to what we call significant others. So, for example, the offspring of the animal, any predators or any prey animals. So these principles should apply to the characteristics of the particular animal and should be all the possible design variables, not just size, should be considered when designing these devices, as well as the technical capabilities and limitations that are of whatever software and hardware is available. So to give you an example here, if you design a tracking device for a red fox, And every device has like a background, produces a background noise. So the background noise produced by the device should not be within the hearing range of the fox, but also it should not be within the hearing range of the animals that the foxes usually prey on, or of the animals who usually prey on the fox. So you have to consider the whole ecosystem when you design such devices, not just the animal who is going to wear them. So Patrizia ran then some workshops with designers applying this framework to redesign those devices that she had tested with cats, and the redesigned device actually turned out to be much more acceptable to the cats than the commercial version. And this is just to show what you can do, how you can improve things if you place the animal at the center of the design process and they, sort of their needs and characteristics. Now, why is this work important? This is a screenshot from like a 2019 sort of Twitter 10 years challenge. And I'm using it here as an example. So the point that I'm trying to make is that for centuries, human technology has directly or indirectly impacted upon the natural environment and on the animals who inhabit it with little regard for their needs. Even when we are moved by the best intentions, it takes a conscious effort to become aware of and take into account the requirements of those who are other from us. Now, systematically focusing on animals as legitimate stakeholders during the design process can help us identify and prioritize their requirements for any technological intervention that involves them directly or indirectly. Being aware of and respecting animals' needs is critical if we are to preserve the natural ecosystems on which we all depend. So now, this was about being mindful of the impact of our intervention, even when we have the best intentions. Now I wanted to look at how working with animals is, and tuning in with them can really help us capitalize on their capacities. This project was about supporting the work of biodetection dogs. And it was in collaboration with our research partners, charity Medical Detection Dogs. And there were various researchers involved here in this project, as you can see here. So biodetection dogs are trained to recognize and indicate the presence of organic, volatile compounds, basically substance or sort of volatiles that come out of substance from diseased cells in biological samples. But the signaling conventions that they are trained to use do not really enable them to express all that they know about these samples. So to give you very quickly, so dogs first are taught to recognize an odor as salient, as important, something we want to know about. And the response they have to this odor, the spontaneous response, is called stimulus response. But of course, the dogs also need to signal to the handler, to the person working with them, that they have found this odor. And for these, they are taught some, conventional signal. For example, sitting down in front of a positive sample or walking away from a negative sample. This taught response is called operant response. Now, the problem with the operant response is that it only allow dogs to produce binary signals. So without expressing nuances, so to say, yes, there's something here, no, there's nothing here. And also, these signals are not the spontaneous way in which a dog responds to an odor of interest, which means that these signals place on the dogs a sort of translation overhead. The dog has to think, oh, now I have to sit, I had to signal in a way that is not really natural for them. And this lowers the reliability of the signal that they produce. So to address these issues, we wanted to develop a technology that would allow the dogs to just be themselves, just respond spontaneously, and via that response, we could infer what it is that they have found, also in a nuanced way. So we decided to use sensors and computing sort of software to capture the stimulus response. So in particular, we decided to record the pressure patterns that the interaction of the dog with the sample when they sniffs produces. And our hypothesis was that these interaction patterns would be proportional to the content, to what was the content of the sample. So here I have, hopefully it works, I have a little video to show you. Okay, there it comes. Come on. Okay. Yeah. So hopefully you see that the interaction with the first stand was different from the interaction with the second stand, and the second stand is where there was a positive sample. So the dog interacted much more with that stand. So using, looking at the pressure data that we collected, we noticed that there were some patterns that emerged. So when the ones in gray that you see on the right hand side are ones from two different dogs who encountered a positive sample, and there are sort of phases to their interaction with the sample. They go in for a first inspection, and if they think there is something there, they come back, they press again in a particular way to sort of confirm to themselves that the content is actually there, that there is a presence of the substance there. And then we see some marks of them exiting the station, that signal the intensity of their interaction as well. So what we also noticed was that these patterns tended to vary with the concentration of the substance. So that could give us also a bit of a nuanced sense of how, for example, is this substance very concentrated? Could that indicate that a disease is at an advanced stage? Or is it, if it is not concentrated, concentration is very low, could that mean that a disease is it's at its very beginning? This information could be very important for diagnostic purposes. So we also found that the pressure patterns were able to indicate, to suggest, to sort of reveal what we call positive, false positives. So when the dog produces the operant signal, maybe he sits, but this is in front of a negative sample. And this is something that without the technology, we couldn't so easily pick up. So these patterns of false positives are quite different from the patterns of true positives. So we also then applied machine learning technologies to see whether we could automate this process. And we are still at the beginning of these research, but of the application of machine learning. But we can see already that our, that we can classify the data that we collect in a similar way to the way the dog sort of classifies the sample. So this is promising work. So the latest version of our technology actually is designed to collect not only pressure data, but also proximity data to see how the dog approaches the sample and how they depart, and also the sniffing activity. And we want to triangulate all these different data to see, and then sort of automate the processing and the classification of the samples using these richer data to see whether we can devise a process that is more, a detection process that is more efficient for diagnostic purposes. Now, why is this kind of work important? So again, we humans are in the habit of manipulating other animals to fit the forms that we like and the purposes that we want to achieve. But in our objectifying interactions with animals, we often fail to see the value of what they have to teach us and to appreciate our interdependence with them. So instead, if we design technology that enables animals to express their own capabilities and conduct their activities in their own way, can help us understand, value, and learn from the knowledge and wisdom they have acquired and inherited through millions of years of evolution, which we cannot yet imitate. So now I wanted to move on to another project, which is to do with actually the environments in which we live with animals and with which the animals have to cope. So this project was about improving accessibility for mobility assistance dogs. And this was in collaboration with our research partner, Dogs for Good, a charity who trains these dogs, mobility assistance dogs, to help people with physical disabilities. And it was a large part of this work was the doctoral work of Luisa Ruge, but there have been other researchers involved over the years, as you can see here. So mobility assistance dogs are trained to interact with technologized environments on humans' behalf, but they have to operate in anthropocentric, in the environments that are anthropocentric, and that from a dog's perspective contravene the most fundamental interaction design principles. These environments lack consistency, they lack accessibility, they lack perceivability, they lack, affordance for canine users. So what we wanted to do was to try and rethink the way in which these everyday interfaces, light switches, door handles, washing machine controls, how these interfaces that dogs are trained to interact with, how can we redesign them in a way that applies good design principles to the sensory, cognitive, and physical characteristics of canine users in order to develop canine-centered controls? And as you see an example here, dogs have diachromatic vision, so blue and yellow really are the colors that they see best, and they can discriminate between best. A dog doesn't have much sort of motor control in their paw. They have much better motor control in their snout. So can we design something that they can interact with using their snout? Or some controls that are large enough that are easy for them to target, that offer a surface that is sort of friendly to them. So dogs do not like shiny surfaces and metal surfaces. They're not ideal for them. So can we just take all of these into consideration to design sort of canine-centered control? And that's what we sort of try to do. But how can we measure the usability, the canine usability of these controls? Because we cannot we cannot interview dogs in the same way that we interview a human. How do we measure how easily they can interact with these things? So Luisa conducted a number of studies, and for example, to compare the use of our controls with the use of standard controls. So in this particular case, these controls were used to open and motorized doors. And so she measured things like, very detailed sort of parameters, like, for example, how much time the dog took to open a door using one control or another. How many attempts did they have to make in order to make contact with the controls? And how many attempts did they need to at contacting the control in order before the door finally opened? So on all these parameters, we found that our controls worked best for the dogs, and particularly the controls that were colored blue, possibly because of greater contrast with the background. But Louisa also wanted to measure the user experience. So how do you measure user experience for a dog? Often we talk to people to find out about their experience interacting with a product or an interactive device. But again, you cannot interview a dog in the same way. So Louisa and Liz Cox, another researcher on the project, they looked at the way in which dogs were wagging their tail as they were interacting with different controls. Because tail wagging is recognized as a behavior that has emotional sort of expressivity in dogs. So that seemed like a good way to start. And so they developed this ethogram that measured the tail wagging position, the direction, and the angle. And in order to try and assess the dog's experience as they interacted with different controls. And again, their interaction with our controls seemed to provide a better experience. So this is these are examples of our latest version of the control. We have a wireless version, which is best for domestic use. You can just plug that in, you plug the appliance on, and then you can use this big blue button for the dog can use it. You can place it wherever it is accessible for the dog, and dogs have shown to be very, very quick to pick up, to learn how to use these devices. Also, the fact that it is convex allows the dog to hit the control from different directions easily, which a flat surface didn't afford so much. And we actually found that one of the benefits is that the human and the dogs can use these to practice together. It's something for them to do together, to learn to use these controls at home. We also have a wired version, which we have installed at the moment, we have installed it in a restaurant in the UK to allow visiting mobility assistance dogs to operate the doors of the accessible toilets. And again, these are shown to have been really quite easy for dogs to use, even if they have no prior training. Here, I want to show you, again, if the video behaves, I want to show you an example. These are my dogs. My dogs are not mobility assistance dogs, but it was very easy for them to learn to use these devices. This is just an example. This is in our university to begin with, where these devices are installed, and then I will show you the examples in the restaurant. This is after like 2 days of training. This is Clara, my second dog, and she had never trained with these devices before, and she only had a couple of hours. This is in the restaurant. Yeah, good girl. So that's, again, just to show you. And why is this work important? Why does it matter that we devise these controls? So there is, of course, we want to help mobility assistance dogs. They help humans, so we want to make their job easier, but there is a bigger point here. which is this, that over millennia, we have created built environments that are increasingly inhospitable to most of the species who occupied the land on which we have built. And at the same time, we have established segregated spaces in which animals are trapped with little control over their environments. So we're now beginning to see how neither of these scenarios are ecologically or ethically sustainable. So by designing technologically supported environments that are inclusive and afford a measure of control to humans and other animals who inhabit them, could help us redress the imbalance between the interests of humans and those of other species, enabling us to create a more ecologically and ethically sustainable society. So the key is we may start with a small control from mobility assistance dogs, but the long-term objective is that we should make the built environment accessible to the animals who dwell in them. So there is a much bigger point to be made in this regard. So now, how do we, so the key is how I said initially that we want to involve the animals in participating in these design processes. But what is participation? Can animals really be considered participants? Can they participate? And how does this participation work? So this project that I did in collaboration with a colleague using Letton and my dog Zina, was to try and explore that even in cases where we trained dogs maybe to do something, can we talk about participation? How do we define participation and participatory spaces? So here we conducted a simple study with Zina to teach her to operate to use one of the controls, like you saw in the video before. And this happened before the scenario you saw in the video just now. But so we had again just with Zina a few days to show her how to use this control. In particular, the yellow control next to if my cursor, this one, particularly we wanted to teach her to use this to open this little door next to it. So the exercise lasted just for a couple of hours each day for 4 days. There were short sections. Zina had a resting place. She had water. She was walked. She was free to move around, and to stop engaging with us. We only used food to entice her, and she was, everything else in her life was normal as usual. So here I want to show you again examples of videos to show how there is a gradual process between the two of us, between Zina and me, in which we gradually get on the same, sort of become in tune with each other as to what we are both doing. So let me start with this. So here I'm trying to point Zina to this control to see whether she would interact with it. And she doesn't understand what I'm asking her. So she's offering behaviors that she has learned in the past give her a reward, like going down. And so she's trying to interpret me, to figure me what do I want. And I'm trying to do things to try and get Zina to engage with me. So at some point I have to start rewarding her I have to lower my bar and to start rewarding her just for paying attention. It's like to just approach the control as opposed to do anything with it. So I have to adapt my expectations and I have to adapt what I do in order to involve her. So there are things, I want her to interact with the control and she wants me to give her treats, but neither of us can at this stage get what we want. So we have to figure each other out to to see how we can get what we each want. So here we have made some progress, and this is where I have started putting a treat on top of the control. So when Zina goes to retrieve the treat, she automatically triggers the control, and this opens the door. And also my colleague went behind the door, and he gives her a treat as soon as the door opened. What this does is to make, so it creates a series of indexical relations between these events. So where there is great consistency. So Zina goes to the control to get the treat, automatically triggers the control. So she learns an association between getting the treat and triggering the control and the door opening, and between the door opening and her being rewarded. So this series of associations enables her to get what's happening, and so what she needs to do in order to get what she wants. And again, we've had to work out this in order to get from Zina what we wanted. The thing to notice here is that by placing a treat on top of the control, I have created a bias to make her to get her to interact using her snout. Okay, this is important. It becomes all clear shortly. So here I have another little video. So here we have changed. We asked Zina to interact with his control here, which is higher up, to see how she would cope with making a greater effort. And so this is what happens. So I place the treat on top of the control to entice her again. And she's done this a couple of times for me. She jumps up to get it and triggers a light. Then at some point, very soon, when I ask her to do that again, she refuses, and she sits down instead. And I keep pointing to the treat, but nothing. I could offer something bigger. I could offer a bigger treat, a more tasty treat. But this tells me that there is a threshold effort that Zina is not willing to cross. So that's it. This is too much of an effort for her. So in the next video, finally, we go. This is a part 2 of the previous one. So I ask her once more, can you do this? And she doesn't do it. So, okay, we go back to the lower control, this one. And look what she does. She approaches it with her snout. And then instead of using her snout, she uses her paw. And this is really a critical point. Shows not only she understands what the task involves, but she chooses to do the task in a different way. She interprets that task in her own way, and she does it in her own, whatever her reasons. So in this example, I wanted to try and show you how this co-design, designing with, working with an animals in this context is an open-ended process of attunement, as the spread would describe it, and or making with Haraway, because what Zina does will inform the design, how the design develops. It's a process, therefore, of incremental orientation, which is an iterative process of incremental orientation towards an end, a final goal, which may never be achieved, like animal-centered design, but which can be gradually approximated, and which involves semiotic engagement, because Zina and I have to both make sense of each other's actions and adapt to each other's actions. It implies volitional engagement, because there is something that we each want. And if there isn't something we each want, the engagement doesn't happen. So there's have to be something that we all, we both want out of these. And it is a choiceful engagement in which each of us can make choices as to how we engage and whether to engage. So this allowed us to identify some key dimensions of what we would call participatory research setups, which is, these are biological salience. So these setups, which relates to volition, these setups have to offer each participant something which they want. This doesn't have to be the same for both. It's what each of the participants want. There has to be something in it for each partaker. Signal reliability, which means that the connections we establish, the associations we establish, have to be reliable for especially for the animal participants to be able to make sense of them. And there had to be engagement options, because it is only when you give options that then somebody can exercise their agency and their volition. And the options don't have to be infinite number, but they have to be enough to enable the animal to express choice, to express their agency. And contingency variations, where, for example, you can offer a smaller or greater reward to see how quickly an animal would, it would sort of be happy to do something, or you could increase the challenge level to see where an animal is willing to go. And so to try and figure out, what it is that the animal is happy to do. So so the fundamental issue is that when we work with animals, we know we are engaging with them in realities that are compromised, in which their agency is severely limited already. But we can work within this compromised reality to gradually change them with their participation. And we have to use the little windows of the little spaces that we create, in which they are enabled to express at least a measure of agency. So to cater for this, to support these processes, we need models of participations that are inclusive and resilient to diversity, so that we can, facilitate the emergence of incrementally co-constructed futures. That's another point that I was keen to make. And finally, when we engage, so if we are to engage with animals in participatory processes, what are ethical ways of engaging? And so this project, this sort of ongoing project and investigation is how do we identify ethical principles to engage with animals. So the current legal frameworks for animal research present substantial limitations for animal-computer interaction research, because they are process-centered rather than animal-centered. So, for example, not all species are protected. The research does not have to be relevant to the subjects used in it. Individuals involved are part of a scientific apparatus effectively. And although the legislation says the harms should be minimized, but this should be done without compromising the procedure. And, euthanasia could be practiced, if convenient, but provided it's done humanely. And, replacement, reduction, and refinement are the best, famous 3 Rs, are best practice, but we didn't think this would be enough. So instead, ACI research, animal-centered research, requires these 3 basic aspects. So the research needs to be, the ethics needs to be user-centered, which means that we work with animals for whom the technology is directly relevant and beneficial, not with any animal, that can serve as a model. It means that the ethics needs to be participant-centered. So it means that we need to protect everyone who is involved in the research in virtue of their role, not of their characteristics, whether the age, the sex, the species. So everyone, just because we just because they are part of the research, are equally protected. And then we need a welfare-centered ethics, which by which we mean the animals need to we need to protect the animals' physical integrity, their health, but also we need to ensure that they have what they want in the way in which we engage them. So in other words, an animal-centered ethics is one in which we always respect the animal's autonomy and safeguard their integrity by working in contexts that are habitual for the animal, by being unobtrusive and undisrupting in our methods, by giving animals control and space for expression, and by using only positive forms of interaction. In short, in an animal-centered ethics, the interests of the individual animal partaker takes priority over the interests of science and society, which is the approach that is used when we do research with children. Now, the final point is that even if we have all these attentions and we apply these ethics, there is something we still cannot exempt ourselves from, which is that we need to garner informed consent for the animal's participation. And so we have defined two forms of consent: mediated consent, which means obtaining consent from humans who know the animal well and understand the implications of their involvement, who have the best interests at heart of the animals at heart and the legal authority to decide on their behalf. But this is not enough. We also need the consent from the animals themselves, which we call this contingent consent, which means enabling the animals to continually assess the situation and choose what to do, whether to engage or not, and how to engage. And we need to appropriately monitor and respond to their manifestation of dissent, if there are any. So this is very important. So consent is not just by the humans, carers, but it is by the animals themselves. And this is very important as an affirmation of the animal's agency. So let me finally conclude by stating a final message. So for millennia, technology has driven a wedge between humans and other animals, increasingly distancing us from them, allowing human interests to prevail to the detriment of everyone else's. This has resulted in socio-economic systems that are environmentally and ethically unsustainable. So it is time to use technology to close the gap by thinking outside the human box. By giving animals representation and control through animal-centered design processes and outcomes, ACI can help us find inclusive and long-sighted solutions to pressing global problems for the sake of all who share this planet. So thank you. And I think I can perhaps stop recording now.
Yes, thank you very much, Clara.
Okay, I'll stop. Pause record. I'll stop recording.